بسم الله الرحمن الرحيم. أعزائي طلبة وطالبات شهادة الثانوية العامة قسم رياضيات لغات، أهلا بكم. اليوم سنستكمل درس الاحتكاك، وطبعا احنا عارفين إن درس الاحتكاك بيتكون من كذا جزء. النهارده بإذن الله هنستكمل درس الاحتكاك بإكزامبل أو بأمثلة جديدة. Welcome my dear student in our math program for secondary 3. My dear student, today we are follow the fraction lesson. My dear student, we are starting by the first example. My dear student, look at the first example. My dear student, body of weight 2 newtons is placed on rough horizontal plane. Two forces of magnitudes 2√3 4 newtons in the same plane act on the body, where the measure of angle between them is 150 degrees. The body remains at rest. Prove that, my dear student, the measure of angle of friction, lambda, between the body and the plane should not less than 45. My dear student, the required proof that measure of angle of friction, lambda, between the body and the plane should not less than 45 degrees. And if lambda equal 60 degrees, my dear student, and direction of two forces don't change also, the magnitude of the force 2√3 doesn't change. Determine the magnitude of the other non-zero force, so that the body is about to move. Determine also the direction in which the body is about to move. My dear student, look at the solution. Look at, my dear student, a body on the same plane, body weight 2 newtons, and two forces 4 and 2√3 act on the body, angle between them 150 degrees. What is the meaning of resultant of the two forces? We use the first force squared, F1 squared plus F2 squared plus 2F1 F2 cosine alpha. Remember, my dear student, alpha angle equals between two forces 150 degrees. Substitution about F1 4, F2 2√3, we find the resultant of the two forces, angle between them 150 degrees, equals what? 2 newtons. Then, my dear student, we know that the body is in equilibrium under action of number 1, friction force of magnitude F, number 2, resultant of the two forces 4 and 2√3 newtons is 2. My dear student, in this case, the body is in equilibrium under action of two forces. The first force, friction force of magnitude F, resultant of two forces 4 and 2√3 is 2 Newton. Therefore, the friction force F equal 2 Newton. Resultant or reaction force equal to, the body is at rest. Then F or friction force smaller than or equal mu s r. What is the meaning of mu s? X uncertain. Coefficient of static friction force. R, normal reaction. F, friction force. Body is at a rest. Therefore, we deduce that F smaller than or equal mu SR, or mu SR more than or equal F. Mu SR more than or equal F means R equal 2. By substitution, F equal 2, we find mu S smaller than or equals 1. This coefficient of friction, static friction force. Mu S equal 10 lambda, this rule. Then 10 lambda more than or equals 1. My dear student, what is the measure of lambda? Shift 10 more than 1 equals 45. Then lambda more than or equal 45, we mean that lambda not should less than 45. Measure of angle of friction, lambda should not less than 45. This is the first required. We translate to another. Mu s equal 1060. If lambda equal 60 degrees, mu s equal 1060 equals root 3. Then 2 root 3 and b 2 forces. By using the rule, then 2 root 3 squared b squared plus b squared plus 2 times 2 root 3 times b times cosine 150 equals what? Equal mu SR. By substitution, this resultant equals root 3 times 2. We find b squared minus 6b plus 12 under square root equal root 3. By taking square the first, highest, or square the left hand side, square right hand side. Therefore, b squared minus 6b equals 0. Take b, highest common factor. b multiply bracket contains b minus 6 equals 0. Then b equals 0, or b equals what? B equals 6. Therefore, tan alpha f2 sine theta over f1 plus f2 cosine theta. This rule to clear that direction of resultant about f1. Tan alpha equals f2 sine theta over f1 plus f2 cosine theta. By substitution, about f2 equals 6 sine 150 over 2 root 3 plus 6 cosine 150 equals what? Negative root 3. This tan alpha. Then alpha shift 10, negative root 3, alpha equal 120 degrees. This direction of resultant about f1. My dear student, we are translate to another title. It's called Equilibrium of a Body on a Rough Inclined Plane. Now we are translate to equilibrium but under inclined the plane about the horizontal. My dear student, from the previous lessons, we know equilibrium under two forces. About its weight, this first force, normal reaction force in equilibrium R equal W. If the force or two forces act on the body, angle between them theta, at the first, we find the resultant of the two forces by using rule square root f1 squared plus f2 squared plus 2f1 f2 cosine alpha. After that, we find the resultant of the two forces and equality by using mu SR. Mu SR means mu S, coefficient of static friction force, R, normal reaction. Now, my dear student, we are translate equilibrium of the body under inclined plane. My dear student, look at the first information. My dear student, body of weight W is placed on a rough plane inclined to horizontal at angle of measure theta, and the body became in equilibrium. Then it is in equilibrium under the action of two forces. Look at, my dear student, a body put in plane inclined to horizontal by angle theta. Look at, my dear student, this normal reaction. If the force F act on the body, look at, my dear student, these are dash W cosine theta. We have, my dear student, more forces act on the body. At the first, my dear student, the body its weight W. We resolve, my dear student, W into perpendicular axis, W cosine theta, W sine theta. Look at, my dear student, R dash, resultant reaction, has two forces. The first F equals R dash sine theta, second R dash cosine theta. We have, my dear student, number one, the force of weight of the body W act vertically downward. Number two, the force of resultant reaction R, which opposite direction of the weight W. R dash means W, my dear student, resolving R dash into two components into perpendicular direction, which are, number one, F equals R sine theta, number two, R equal R cosine theta. Resolve W, number one, W cosine theta, number two, W sine theta. Then R equal W cosine theta, F equals W sine theta. Now we are translate two important example. My dear student, look at this example is very important. Body of weight 90 gram weight is placed on rough inclined plane. It's noticed that the body became about to move under the action of its weight only when the argument of the angle of inclination to horizontal equals what? Equals 2/3. If the same body is planed on a rough horizontal plane in the same roughness of inclined plane, and a tension force act on it in a direction makes an angle whose tangent is 3/4 to horizontal upwards, lying in vertical plane to make it about to move. What is the required? Find, number one, magnitude of tension, number two, magnitude of normal reaction, number three, magnitude of resultant reaction. My dear student, we have three requirements. First required, magnitude of tension. Second required, magnitude of normal reaction R. Number 3, magnitude of resultant reaction R dash. Look at the solution. My dear student, look at this is a plane horizontal, body put in the horizontal. We have weight and R. What is the weight? W. R reaction force. We have tension. Look, my dear student, T, we resolve T or tension about two perpendicular, T cosine theta, theta equal 30 degrees, and T sine theta. My dear student, we have equation of equilibrium. Weight equal 90 gram watt. Then, my dear student, we have W, weight equal 90 gram watt, and R, normal reaction force. We have tension. This is a force inclines the plane by 30 degrees. We resolve T about two perpendicular axis, 2 cosine theta or 2 cosine 30, and horizontal in horizontal, and T sine theta or T sine 30 in vertical axis. And mu SR equal Fs, static friction force. Look at, my dear student, the body is about to move. What you mean? Under action of weight only. Therefore, measure of angle of friction equal measure of angle of inclination of the plane to horizontal. Therefore, mu s equal 2/3 from given equal what? Coefficient of friction force. The body is placed on horizontal plane having the same roughness of the inclined plane. Mu s, coefficient of friction between the body and horizontal plane, equal 2/3. Mu s equal 2/3. Therefore, look at tan theta equal 2/3. Look at, my dear student, 3/4 is 10. Then sine equals 3/5, cosine 4/5. If we have theta, tan equals 3/4 or mu s equals 3/4, then by using Pythagoras theorem, we find the third side equal 5. When find cosine theta 4/5, sine theta equals 3/5, tan theta 3/4. The body is about to move. T cosine theta equal mu SR. 4/5T equal 2/3 R. This is number 1. Number 2, R equal R plus T sine theta equal W. By substitution, R plus 3/5T equals what? 90. This equation number 2. My dear student, we have two equations in two variables unknown, T and R. T tension, R normal reaction force. By using Ohmting method or substitution method, therefore, from 1, R equals 6/5T, substitution in equation 2, therefore 6/5T plus 3/5T equals 90, then T equals what? 50 gram watt. This is the magnitude of the tension. Magnitude of the normal reaction equals 60 gram watt. What is the meaning of resultant reaction force R dash. R dash, this rule, equals R plus R multiply square root 1 plus mu s square equals 60 multiply square root 1 plus 4 over 9 equals 20. Then R dash equals 20 root 13. Therefore, equals 9 meter watt. Now we are translate to another example. Look at, my dear student, body of weight 40 Newton. Rest on a rough plane, inclined to horizontal with an angle whose tangent 3/4. Body of weight 40 Newton, rest on a rough plane. This rough plane inclined to horizontal with angle whose tangent 3/4. If the least force acting on the direction of the plane upward to keep the body in equilibrium equals 16 Newton. My dear student, the least force acting on the direction of the plane upward to keep the body in equilibrium equals what? 16 Newton. Find the coefficient of static friction between the body and the plane. The required, find the coefficient of static between the body and the plane. Look at the solution. My dear student, the body, look at the plane, body both in the plane inclines the horizontal by angle. The body has weight and W. Its weight W, we resolve W cosine theta and W sine theta. We act the body by the force B equals 16. Look at, my dear student, angle between the plane and the horizontal theta. We resolve W cosine theta, W sine theta, and we form the two equations of equilibrium. Let B is the least force and direction of plane upwards and keep the body in equilibrium. Therefore, the body is about to move downward. Why? Because B least force and direction of the plane upward. The body about to move downward. The friction is limiting mu SR. Two equations of equilibrium R equal W cosine theta, this number 1. R equal 40 cosine theta equal 4 over 5, then R equal 32 Newton. The first equation, R equal W cosine theta, W equal 40 cosine theta equal 4 over 5. By substitution, R equal 32 Newton. The second one, B plus mu R equal W sine theta. By substitution, B equals 16, R equals 32, W 40 sine theta equals 3 over 5, mu equals what? 3 over 5. Static friction force 3 over 5. Look at, my dear student, if we have theta 3 over 5 equal sine 3 over 4 tan 4 over 5 cosine. My dear student, look at another example. Body of weight 19 kilogram watt placed on a rough inclined to horizontal at an angle whose cosine is 12 over 13. we have body. Its weight 19 kilogram weight, placed on a rough, inclined to horizontal, at angle whose cosine is 12/13. The body is pulled horizontal by a force lying in the vertical plane passing through the line of the greatest slope, which makes the body about to move upward the plane. If the coefficient of static friction between the body and the plane is half, 1/2, the required find magnitude of the tension force. My dear student, if the coefficient of static friction between the body and the plane is 1/2, find the magnitude of the tension force. Look at the solution. My dear student, look at this horizontal and plane inclined horizontal. Body is both the plane inclined the horizontal by angle theta. Body has a weight and normal reaction. Look at, my dear student, we have W, its weight. We resolve this W cosine theta, W equal 14, and W sine theta. Look at, my dear student, we have mu SR and B horizontal or parallel to horizontal. We resolve B about two perpendicular axes. Look at theta 12/13, its cosine. Then we find the third line by using Pythagoras theorem equal 5. Then sine theta 5/13, cosine theta 12/13. Therefore, the body is about to move upward the plane. Therefore, the fraction is limiting, equal what? Mu r. Two equations of equilibrium. Number one, r equal W cosine theta equal B sine theta. R equals 19 times 12/13 equals B sine theta equal 5/13. Therefore, this equation number one. Equation number two, B cosine theta equals mu r plus W sine theta. Therefore, B times 12/13 equal half times R plus 19 times sine theta 5/13. Therefore, we have two equations. 12/13b equal half r plus 95/13, this equation number 2. From 1 and 2, we find the value of B and R. B equal 22 kilogram weight. My dear student, by the end of the lesson, I am very happy to spend such time with you. Thank you. Goodbye.